Our second lesson is about electric energy and power. First, let us going to define the definition for these electrical quantities. Electrical energy is a form of an energy used to run or operate various electrical devices. And the unit for this electrical quantity or the unit for electrical energy is joule. And then the other common unit for this quantity is kilowatt hour. While the electrical power, it is the rate of consuming the electric energy, and then its standard unit is watt. The other common unit is kilowatt. So we designated P, a symbol for the electrical power, and W for the electrical energy. So the formula or the equation we're going to use is power will be equal to electrical motive force or the voltage times the current, and then the electrical energy will be equal to the power times the time. So our example number 4 states that a radio receiver draws 0.9 ampere at 110 volts. If the set is used 3 hours per day, how much energy does it consume in 10 days? Okay, so in this problem, we know that first thing to do is we are going to state the given in the problems. So 0.9, this is the current, 110 volts, this is the electromotive force, and then we have 3 hours per day, so this is the rate of the radio, and then 10 days consumption, this is our time. So what is required now is the energy of the radio receiver in 10 days. So to find this, to find the required in the problem, which is the energy or our W, so we will be using this formula. This is our required. Is the time given? Yes. Is the power given? No, not yet. So we are going to solve this one using our formula here. So power is again is equal to voltage times current. So 110 volt times 0.9. So we have now 110.09 is, so 110.09 times 0.09. I mean 0.9. We have 99. So we have 99 watts or 0.099 kilowatts. So now next is to solve, we can now solve for the electrical energy using the formula P times T, power times time. So our power is 0.099 kilowatts. So times the rate, 3 hours per day. Okay, this is the rate, and then we are going to, so if you can observe here, 3 hours per day, this is the rate. So how are we going to cancel or to delete or to cancel this day? We know that we have a given 10 days, so just multiply this 10 days into the equation. So we are going to cancel out the days. So 0.099 kilowatt times 3 hours times 10, we have 2.97 kilowatt hour answer. So take note that you can solve in another way, or in such that the unit is not in kilowatt hours, it's okay. So as long as there is no boundaries or it is not required in the problem that you will be having, you should be solving this at this kind of unit, so that's okay. So our example number 5 is we have here a motor has a rating of 4 horsepower. Determine the power in kilowatt. So the unit is required in kilowatt. Its efficiency assuming a power output of 2500 watts. So again, so state the given. For HP, horsepower is in under the power. HP or horsepower can be converted into watts. So okay. So we have also a given here. We have a power output 2500 watts. So what is required? Determine the power in kilowatts. So we have a given power input for HP because power rating means power input. So what is required in the problem is the power in kilowatts and the efficiency of the motor. Okay, so first is we are going to solve for the power input in kilowatts. So we know that 1 HP is equal to 746 watts. So 4 HP times 1 HP, so the numerator will be in watts, 746. So 4 HP times 746 watts, so cancel. We have 2984 watts. So this would be our answer. So to solve for the efficiency, so it is not indicated in our equation. So for your information, efficiency this is equal to the power output divided by the power input. So using the formula, direct substitution 2500 watts, and then so this should be a 2984. So 4 times 746 is 2984. Yes. So in this problem, so let's going to solve. So 2500 divided by 2984. So this should be 9. This should be 9. So our answer would be 83.78%. So this is not the answer. Our answer should be 83.78%. So this is our answer.